Okay, let's look into the question number 4. Okay. Right. A spring-loaded piston contains 1 kilogram of carbon dioxide. Okay, so we have the question number 4. Right. Again, same problem. I have a piston cylinder device. But before it's always we start with the word steam or water. But this one is called at the start with the word CO2. CO2 is what? This one is what? Ideal gas. So when it is ideal gas, you do not need thermal table. Okay. So now you can leave this table. No, table have to be away because this is water. No more thermodynamic table because this is ideal gas. Remember that the ideal gas, the secret weapon is what? Yes, PV equals to MRT. Okay, so the only way to solve is PV equals to MRT. This is the powerful equation. And then, how to find the U? Okay, and U equals to mCV, temperature minus final minus initial. Okay, right. Okay. It's the same question that when we learned about this energy equation. So E in minus E out equals to delta E of the system. Okay, because this is what? The closed system. So Q minus W equals to delta U. Okay, the delta U for ideal gas is M T2 minus T1. Okay, the final minus initial. Okay, your T2 minus T1. So Q equals to W plus M CV T2 minus T1. Okay, you don't need to find U from the table, right? Because this is the ideal gas. Right, now, okay, because PV equals MRT is what? Okay, so kenapa kita cari? Why do we need to find V first? Okay, because remember that's the previous question. Work is what? Work is area underneath. So PV. So the questions are, okay, look at the second sentence. The system is heated from 1 kilopascal 25 degrees Celsius to 1000 kilopascal, reaching the temperature of 300 degrees Celsius. So from 100 kilopascal into second sentence what? 1000 kilopascal. We don't know whether it's here or here. Okay, so let's start. Okay, so state 1. P1 equals to 100 kilopascal. T1 25 degree Celsius. Equals to valence to? Yes, 298 Kelvin. If you not remember, this one is what? 245 plus 273 to convert to Kelvin. Right. Okay. Because when we use this formula, T have to be in Kelvin. Okay. So V1 equals to mR T1 over P1. R is given by the constant, given by the question is what? M is given by the question. So initial state ideal gas is CO2 at M equals to 1 kilogram. This is come from the first sentence from the problem. So mass is equal to 1 kilogram. R is what? 0.1889 kilojoule per kilogram dot K. Automatically the value T1 should be in Kelvin. So 298 Kelvin. So you can simply abolish the K over P1. P1 is what? 100. So must be in kilopascal. If the question later on give in a megapascal, we have to convert into kilopascal. Okay, this one is kilo, so kilo we can scratch this up. Right, so we have the value of 0.5629 meter cube. Okay, right. So state 2 from the third sentence. Okay, because the first sentence just say that initial contain 1 kilogram, so that is not a state of process. Okay, so just that's a general overview about how many kilogram are there, what is the mass for the carbon dioxide to be inside this pistons in the device, right? Okay, so P2 from the third sentence, from the second sentence, the system is from 400 to 25 degrees Celsius to 1000 kilopascal, average temperature of 300 degrees. So P2 equals to 1000 kilopascal. So T2 equals to 300 degrees Celsius. From the same sentence, but they have two types of phases. This phase is change. Okay, so equivalence to what? Yes, 573 Kelvin. Because what? 300 plus 273. So you got 573. Okay. Later on in test, they will ask you question how to convert temperature. So that's one of the hint for the midterm exam, right? Okay. So now let's move on. Okay. So find volume 2 or the volume of the second phase, mRT2 over P2. So 1 kilogram. Okay. You might wonder why the mass is the same. Because it's a closed system, the mass will always remain the same. R is 0.1889, because I don't have to repeat the use of units, so assume that you guys are familiar. 573 over 1000. Okay, so we get the value of 0.1082 meter cube. So graph PV, so this one 0.6, state 2 0.18, so 0.18 is here, so means V2 should be here, so this one is 0.1052, so 0.56. So very logical, very logical sequence. So 0.56. So from here to here. So state 1 to state 2. You can put an arrow here. Straight line. See? So the W is what? Area underneath. Okay? Right. So whatever this one? So we calculate W, area, and a half P1 plus P2 plus V2 minus V1. Okay, 100 kilopascal plus 1000, always in kilopascal. V2 is what? 0.5629 minus 0.1082. So we got minus 250.1 kilojoule. Balik 0. So 0.1082 minus 0.5629. That's why we got the answer of minus 250.1. Yeah, right? Okay, and then the question asks calculate the heat transfer of the steam. So what are the heat transfer? Okay, so A, so Q equivalents to W plus M CV T2 minus T1. Right. So W is what? Minus 250.1 plus M 1 kilogram. CV is given by the question, constant value 0.657. This one is T2 what? 573 minus 298. Okay, so dapat value minus 69.4 kilojoule. So that's mean that he is leaving the system. Okay, so we got two value. That is question A and part A and B. Right. So we finished the question with number 4 for tonight.